Good afternoon. We are the other half, as you see in the agenda. So half of the conference is now at site visit, but we are very thankful and grateful that you are with the other half with us. So my name is Atanas Georgiev. I'm Dean at the Faculty of Economics and Business Administration at Sofia University, where I lead the energy-related programs. And I'm thrilled to be the moderator again at the Resource Southeast Conference, the biggest event in our country, I believe, in renewable energy. So in this panel, which actually closes the conference, we will have these gentlemen from different energy-related and innovation-related companies. And I will present them as they go in the slide. So Mr. Vladimir Tabutov, who is the CEO of Hex Solar. Nice to have you here. Welcome.
Thank you.
Engineer Simeon Beloreshki, who is General Manager of Stratum Engineering. Nice to have you here. Raymond Decorvet, who is Senior Account Executive at MAN Energy Solutions. I do hope that we have him online. Maybe he can confirm if he's with his microphone on. And Mr. Dragomir. Hello, Raymond. Nice to hear you. And Dragomir Ivanov, founder and CEO of Hydrogenera. So in order to fulfill the promise we have, the session will explore the potential of other energy-related applications of renewable energy. You know that sometimes we focus too much on electricity-only solutions, and the larger challenges we currently face as society are related to the whole energy consumption package. So we'll talk about heat pumps, agrivoltaics, floating solar thermal storage, and power to different types of resources, power to X, to tackle the other half of the energy challenge that we all face. So in the panel, we have very interesting examples, and we'll see the presentations of the gentlemen here, which will remind us that in order to go forward, we need to explore innovation. We need to explore energy-related innovation and share the best practices and examples how we actually reach the so-called liberalization 2.0. So if liberalization 1.0 is changing your supplier of energy, liberalization 2.0 is about prosumerism, about being able to deliver the energy services at home, at the industry, for the system, from different new innovative energy resources. So I suggest that we go by the order of the panel as it is announced in the agenda. So Mr. Tabutov will be the first one, and this is the magic wand for the presentation.
Thank you very much. Good afternoon, everyone. Thank you for staying with us this lovely afternoon. I'll briefly share the experience of Hex Solar in different solar applications which go beyond the traditional free-field systems, and we'll be happy to discuss any of the challenges that you face in the solar industry. Hex Solar is a global company that delivers CPC services and also develop projects, and I will share some of the projects that we have currently done and also currently executing in order to give you a bit different perspective of a traditional solar plant. So the first project that I want to present is in France, a floating power plant that we did 2 years ago. It was an offset initiative by a French developer together with a French municipality. Again, the corporate takeover of the electricity there was a municipal player, but since in France there is a huge scarcity of land, this project was realized on a pond in the middle of the municipality. We were doing the installation. There were quite a lot of different challenges that really somehow determine the capex differently of the project that typically people will think about. So while realizing this project, we had to hire scuba divers, for example, to do the installation, have very different set of risks that we had to take into consideration, which was quite challenging one. But this is a good example of how different land can be, or water can be used as a home of a energy generating facility. Another project that we are very proud of is currently that we are realizing in Austria, is the biggest and largest agri-PV project in Europe. It's 120 megawatt that was developed very quickly due to the legislation changes by a local utility company. So our client is a utility company that delivers to thousands of households in Austria. There we are implementing a brand new technology of trackers that are elevated and we co-located and actually preserve the agricultural status of the land. So it's a hybrid energy generation, let's say. If you look at the food and the electricity as different energy sources, this is a very, very wonderful example. Here, as this is a quite new technology, the demands from the final client are very strict. Since the plant should last for at least 40 years, we are requested to fill in roughly about 8,000 quality protocols, because it's a new technology. Nobody did such a huge power plant as an agrivoltaic, and we are implementing different measures that nobody faced before. So there are extreme, let's say, quality measures that need to be taken into account that somehow also skew the capex. It's different from what traditionally you would see in a financial model. Another milestone project that we are very proud of, and I think this is one of the good examples to share here on the corporate sourcing. It's a project that we realized in the Netherlands with a state-owned company, where we had to do one part of the project as a co-location with wind and battery, which was extremely challenging to really manage. And the second part of the project, we are feeding the electricity directly into the grid of the biggest ammonia producer in Europe. So it's one plant that services a corporate PPA and also sells on a direct market with a hybrid solution of wind and battery and solar co-location. So, I mean, if just only talking about it probably sounds a good implication and also a good idea to have this co-location, but when it comes to realization, there are a huge amount of challenges that if you haven't faced, it's very, very difficult to manage. I mean, one thing is theoretically co-locating plants and generation. Another thing is practically realizing that. We are in the O&M phase of these projects, and believe me, it's very, very difficult to curtail on time, to switch on the battery on time, and so forth. So it's we have to learn. Everybody has to learn a lot still about those projects and how to really get the financial model implemented in reality. And the third project that we are currently executing, this is just a demo of it. We have signed as a company a corporate PPA with one of the biggest brewery producers in the world, where they have shared 4 locations with us in Germany, where we are doing the investment corporate PPA for 15 years and then operation and maintenance of their facility. It's a very, very standard solution when it comes to our corporate on-site PPA, where we also have a co-location with battery. This project is in engineering phase now, and we'll be happy to share in the coming events what is our experience there. So we hope we will bridge this, theoretical to practical challenge very soon and get more experience as a EPC company delivering this kind of co-located projects on the corporate users.
Thank you. Thank you very much,
you.
Mr. Tabutov. Your presentation is a lot like an intro to many important topics. One is that we will see more and more ESG-related investments and co-locations, as you mentioned, of industrial and energy facilities. And let's not forget something that we always had, the energy water food nexus. So using efficiently the land and water resources together with renewable energy is a really good example. So thank you very much for sharing, and we'll come back to you after the other presentations with some questions. Now I'd like to give the floor to Mr. Beloreshki from Stratum Engineering. I know that he also has some very interesting examples of technological advancements applied in the practice. Screen is also yours. Yes.
I have run out a little bit of a voice, but we'll try to do my best. So first of all, just an important information for you. I may be the only guy who never worked in the renewable industry. So all my life has been in a energy sector, coal-fired, gas-fired, oil and gas, petrochemical, you name it. But that doesn't mean that we cannot contribute to the whole decarbonization that we are all after. I believe this is the last slide, so okay. So I will start with that. So Stratum Engineering is actually a joint venture between two companies, Oscarel and Smartsys. They are all on the market. These are Bulgarian companies with more than 20 and 25 years on the market. With the people who are engineers, they started from bottom up and they brought their expertise to the business level. And where the quality and on-time delivery, of course, is not just everybody saying is doing it, but for us, this is a must. Very short about our vision, why we're here. So we are all committed to decarbonization. That's the first thing. Then we believe that the electrification will be everywhere. So the question is how we can do this much faster, that everybody needs. And because we are cross-industry, cross-OEM, we have the capability of really advising the end user what are their needs and what they want. And I want to make this very, very good, very detailed what we mean. Normally, standard people, they read the RFQ or RFP, whatever you call it, and they said, okay, this is what customer wants. And for 90% of the people, what customer wants is something that you have to comply, otherwise, you know, the consequences. But if you have a chance to elaborate a little bit more what customer needs, because what they have put in their RFQ is their interpretation of their needs, which is based on maybe old knowledge, bad practices, good practices, it doesn't matter. That this is where we want to be with our expertise, with working with so many different industry and customers in industry and OEMs, right? We can eventually come with a solution which is win-win for everyone. So we have a little bit more freedom to do that. Just to share with you, I was working 25 years for a big multinational company, and all the time I was working there, it was more or less kind of a driven, it was Honeywell, it's not a secret. So it was more or less, let's go with more scope of our company, because this is how business works, right? So sometimes you are pushed to sell something which you internally feel that you may not be the best one. And when you are young, you can absorb that. The more you're growing and the more mature you are, you said, okay, should I do really that? It's not lie, right? So this is the area we are a little bit focused, and we believe that we can provide that valuable value proposition for our end users. There is something in the slide, sorry. This should be one slide, not sure what is it. Anyway, two things is here. The first one is the projects map. So this is the world where we have sold our projects. We are doers, right? So we are not winning projects. So anyone who won the projects and they need anything which is related to electrical system and automation system, they come to us. eventually. The funny thing, somebody may find it shocking, Oscar L, for example, they never had trade department or salespeople. So people know them because of their quality of work. Things are now getting changed a little bit, so we have now business development lady. And the other thing I want to just to give a little bit, what is the latest interesting thing we did. Picture is not very good, but a lot of people are talking about hydrogen. So I will not take your. So he's having very tough job because the electrolyzers are known for many years. They are used today in almost every electrical power plant. They use the hydrogen for cooling of the generators and etc. But this is on a very small scale. Having a big scale electrolyzer is a big challenge, and believe me, everybody in the world is learning how to do that. So what we did, So what we did here is how it works. Okay, on the left side, this is for our partner in Holland. They were doing an electrolyzer, 10, 15, and 20 megawatt electrolyzers for a steel factory in Finland. So we came together and we designed the cabinet. So it's actually the container. So this is the power distribution for the electrolyzer. So they're building the electrolyzer. We did the power distribution. And believe me or not, this is one of the most critical things. We believe it's kind of easy, but because of the scale and because of different challenges of having 4,000, 5,000 amperes in a small area. So it's a lot of constructional and design challenges. And the design is going to change most probably after the first trials and etc. So this is a kind of an exciting things. We work for nuclear as well. One of the major customers here in Bulgaria is a nuclear power plant in Kozloduy, and now Rubis. So our 80% of our production is going for outside. In Bulgaria, we have focused on these two major customers. And this is a little bit for us. So we are having almost 8,000 square meters of a factory space next to Sofia. We will be doubling this capacity. We are expecting groundbreaking beginning of July. And as you can see here, we have office area, we have factory area, and the other one is FAT area. This is a factory acceptance test. So we are not just building here, we are testing it here. And currently, even today, there's the final days of the factory acceptance test for Temelin nuclear power plant in Czech Republic. We are doing some job for them. And of course, big portion is our engineering stuff. So we are doing a lot of SCADA systems for, again, electrical and automation, for waste treatment plant, oil and gas facilities, and for national strategic reserve for grain. So that's for the company. But we are doing, and later on we will put a little bit more on the discussions why we believe there are so many other things that needs to happen. Thank you.
Thank you very much, Mr. Beloreshki. And when we talk about innovation, this is a very nice example of it. You know that the net zero industry topic is now maybe in the forefront. Maybe it will be also like a flagship topic for the next European Commission, if it's not too late. So these are examples in the whole panel you see here of industries that support the energy transition, because it's always good when these technologies are invented, produced, also here and not only imported. So with this, I now pass the baton to Mr. Raymond Decorvet, Senior Account Executive at MAN Energy Solutions. I hope that you're still online with us and that we can hear and see your presentation.
Yeah, thank you very much. Yeah, thanks a lot. So, hello, Sofia again. This is Switzerland, Zurich calling.
Hello.
And, I'm very glad. Can you hear me?
Yes.
Yeah. So I'm very glad to be here. Unfortunately, not in person, but nevertheless. So I also prepared 3 slides, which I would like to share with you. First of all, MEN is an international company. We are about 14,000 employees worldwide. And our latest strategy is actually high temperature heat pumps, carbon capture, and also hydrogen production, where we have modules. And today the topic is heat pump, large scale heat pumps, and I like to call it mega heat pumps. And as you probably are not all aware of, that mega heat pumps at very, very large scale are highly relevant to the energy system. And I hope I can lead you through and that you are believing me afterwards. So first of all, of course, heat pumps, they help a lot in the energy transition, whether it's in the energy transition, but also on the heating transition. They not only decarbonize the heat production for instance, district heating, but also in the industry. But you have to know that also each heat pump is producing cold. So this is first. Second, heat pumps can do a great job actually in when we have some energy crisis, and most countries currently suffer that they don't have enough electricity at some time. So if we integrate renewables with our heat pumps, there is no better and more efficient technology to produce heat and cold than a heat pump. If you are familiar with the heat pump, we are talking about COP. What does that mean? Let's assume we have on the hot side a COP of 3. That means 1/3 of the electricity is translated into heat and multiplied by 3. So we have 3-time thermal output with one single electrical input. And if we combine now the heat and the cold together, then with a heat pump, we can achieve COPs much bigger than 5. So very, very efficient. Secondly, with a large heat pump, we also can produce thermal storage. Thermal storage, in my opinion, is the lowest hanging fruit, actually, to utilize meaningful overcapacity of renewables, which we very often have in many grids. And thirdly, a heat pump can also even help to balance the grid if we have large fluctuations coming from renewables. And our experience is that if we have 20% plus renewables in the grid, then the fluctuations are already becoming a tough topic and needs balancing. And heat pumps, what we can offer, we can even play in the primary reserve. That means that we could increase or lower the electricity input of a heat pump by 8 to 12 megawatt of electrical in less than 30 seconds. So this is really, really helping balancing the grid a lot. And last but not least, sector coupling to exploit synergies among different business sectors. And here is a slide which I would like to show you. Here in the middle, we got a very large heat pump. It can serve, of course, many different market players to deliver heat and cold. Very often, one part is going to be wasted. Most of the time, it's the cold. But if we can utilize the cold as well for other applications for cooling, think about data centers or H2 production or carbon capture. They all need cooling. But this is only on the output side, but also think bi-directional, because all data centers, H2 production, but also carbon capture could also provide heat, waste heat actually, which is the heat source for the heat pump to produce the heat and the cold again. And here at the bottom again, you see also the renewable integration and also the grid stabilization, which could be done with a heat pump, as well as the thermal storage we could build, which is also called long duration energy storage. And now I show you a example of our lighthouse project in Denmark, in a harbor city called Esbjerg. The point is actually that they want to get rid of the coal CHP plant, which was delivering the heat to the district heating network. And now they are going to implement, and this is currently under commissioning, 2 very large heat pumps of ours, 2 times 30 megawatt of thermal. And we are delivering temperature levels between 70 to 90 degrees. The return temperature, however, from the district heating network is pretty low. And the innovation about this is that it is a CO2 heat pump using seawater as a heat source, which means that we are taking out of the sea 4,000 to 5,000 liters a second, and we take out about 2 Kelvin. And even in wintertime, when the water is about 2 or 3 degrees, we still take out 2 Kelvin and reach the 90 degrees, thanks to the CO2 behavior. And we achieve very high COP in winter of 3.3, and in summer even 4 and more. And with this, we are able actually to heat about 25,000 households with 100,000 citizens. And compared to the coal CHP, which is going to replace with these 2 large heat pumps, we are having savings of 60,000 to 100,000 tons a year. So that's it from my side for the moment. Thank you.
Thank you very much, Raymond. Very interesting indeed, and we hope that there are more systems like this. Heat pumps is a technology that is very much relied on for the electrification of the whole energy balances that I mentioned earlier. So hopefully we'll get to such a point. And now the presentation of Mr. Dragomir Ivanov, founder and CEO of Hydrogenera. I was impressed by his bio that actually when we talk about innovation, he has his own patents. So this is the way to go, as we mentioned, and thank you very much. The floor is yours.
Something happened with the microphone. Yeah. Hello, everyone. Good afternoon. Maybe 30% of the audience, but
The other half.
yeah, the other half, the better half. Sorry, maybe here it will be better. Yeah. Today we will speak about hydrogen, and I will try to briefly explain some simple things about the hydrogen and try to convince you that it's not something dangerous, and that even it's not so innovative nowadays, and that this is not something that will happen in the future, but we have the technology readiness today, and we can use it for decarbonization, and not only for this. I mean that hydrogen can be used also as a fuel, like the natural gas. And yeah, maybe it's really close to the business model of the natural gas. So for everyone, it will be easier to imagine how we can use hydrogen. In the presentation today, I will briefly show you one simple example of something that most of the people are presenting as Hydrogen Valley. That means that in one facility you can have everything in one place. I mean, the green energy, the hydrogen production, the storage, and after that, the utilization of the hydrogen in in the industry, in the houses, in the transport, almost everywhere. You can see on the first slide how it looks like. So it's not so complex. Of course, everyone is asking how much does it cost, and they're saying that the hydrogen is very expensive and that without any kind of support it will be hard to develop such kind of project. And that's why I will start with the most common question: how much it costs and what will be the payback period. Especially this slide is for hydrogen facility of 1 megawatt. As you can see, the payback period is almost 5 years. And this is without any grants. For every investor, this is a really good period of payback. So on this question, is it too expensive? No. Nowadays, it's not too expensive, and in the future, it will become even more affordable as a technology. What I mean by one project for 1 megawatt, because everyone is asking for the duration. The duration of such kind of project could be easily 15 years. Of course, the whole OPEX is inside of the projections. So these figures are absolutely real. What is included in such kind of project? Of course, the electrolyzers are the most important part of the project, but only with electrolyzers you cannot make the whole picture. Of course, you need the renewable energy. It could be PV, it could be wind, it could be anything green as a energy. Of course, the storage of the hydrogen. Also very interesting topic nowadays and very interesting discussions with some of the customers. Again, with the storage, a lot of myths. One of my favorite is that the hydrogen is going through the walls of the metal storage tanks and magically is going in the atmosphere, which is not true. Today we have really huge business and a lot of companies producing tanks of hydrogen under low pressure, under high pressure, from metal, from composite materials. And even the standards now in Europe are 350 bars and 700 bars for the trucks as the hydrogen storage tanks. In US, they are storing the hydrogen under 1,000 bars. So the storage and the transportation, I will say it again because it's important, is pretty much similar like the natural gas. It can be stored under high pressure, under low pressure. It can be liquefied, and also it can be something happened with the microphone. And also it could be stored in a so-called storages metal hydrate. But we can talk about this later. One of the most important questions in such kind of facility is also the oxygen. Because we can see on most of the projects in Europe and not only, the oxygen is not part of the business model. Because most of the producers of electrolyzers are throwing the oxygen in the atmosphere during the production. But we think that the oxygen is also a very valuable resource. It has its own price, and it also can be stored directly after the production. Of course, it needs a little bit treatment, but it's not so complex. That's why when you put everything in one piece, also the compressors, you will have one good project on a very good price and with a really good payback period. So the main point of this presentation is that hydrogen can be used now. It's not something in the future. And it's not so dangerous. And actually, it's not something new. So yeah, we can use it to make the decarbonization happen.
Thank you. Thank you very much, Mr. Ivanov, for the investment analysis and the interesting technologies. Listening to all the presentations, I think there are two halves of the question I want to ask you. And one of them is, what could be the next best partnership to look for, looking at the conference and as a whole, the sector? So what would be the low-hanging fruit for first partnerships to explore further in promoting new technologies, and not so new, as you said, but also technologies that are already around? And what are the factors that are hindering? So we discussed actually before the panel started, we had a mini panel here in the front, and I'm sorry we didn't record this because it was very interesting when we shared some of the challenges when new investments have to happen, but we can do like a summary of that mini panel that we had here in the front, if you wish. So I'll start from Mr. Ivanov and going back to Mr. Tabutov in the end, and ask all of you these two questions, and maybe then we'll open for a question or two in the audience.
Yeah. Thanks for the question. As I try to present to you, yes, the hydrogen is here, and as a technology we can use it, but of course, alone as a solution, it's not possible to find a solution for the problem. I mean, everyone here, all the specialists in the different directions, we should work together. Because I will give you a simple example today. We also can see in Bulgaria what is happening with the prices of the electricity. For example, for the hydrogen, you need green electricity, and the best synergy is to build together these kind of projects. I mean, the solar or the wind together with the hydrogen facility. And only in this case, I'm talking from our point of view, we can achieve a really good and profitable, from business point of view, project, and at the end to deliver really clean fuel for the industry and for the houses, because in my opinion there is no need to reduce the speed of development of the world, just we have to moderate the way how we can do it.
Yeah, and listening to your presentation, you also mentioned the states, but even in the magazine I'm publishing, Utilities, we also had several analyses on this topic. So the states have quite more developed legal and regulatory framework even for gas. Yes. If you go to the integration with the other sector, with the gaseous fuel sector. So do we need to do something, let's say, in advance here as a national market, regional, or wait for the European directives and then on?
Actually, if we have to be precise, we don't have to wait because they're already happening. I mean, I think that every 2 or 3 weeks we have another directive from the European Union according to the hydrogen market, according to the legislation, and everything connected to the hydrogen and the green energy. I will give an example with Romania. They're quite ahead than us in this topic. But I think that we are not so delayed. I mean, we are back to back with some of the countries from the European Union, but of course we need a lot of work here, and I hope that the state will do their job.
Really, I hope this message gets through to the policymakers when they deal with their more important tasks.
Yeah, they have more important.
Okay. Sorry. And Raymond, if you still hear us, what do you think about the possible partnerships and challenges that we have to tackle first?
Yeah, I think first of all, we need partners because otherwise we cannot cope with this big demand, which we currently see in the market in regard of the demand of large heat pumps. On the other hand, I mean, heat pumps, they can support the industry at large scale because most industry processes are dealing with temperature levels below 200 degrees or steam, and this already can be done and replaced with heat pumps. But the large-scale heat pump market is still kind of in baby shoes. That means that a lot of lack of knowledge is available. People don't know exactly what large heat pumps are capable to do. And what also is hindering the faster deployment of heat pumps is the brownfield. It is pretty much difficult to implement a heat pump in an existing plant. If there is, of course, a oil or gas boiler, it can be replaced by a smaller heat pump already today. But if you want to replace the whole heat demand of an existing plant with one large heat pump, this is possibly impossible. But if you would build a new plant from the scratch on greenfield, then definitively customers would invest in a heat pump. And lastly, it is also the low gas price and relatively the high taxes on electricity, which are currently hindering that customers are investing more and are aiming more for investments into heat pumps. And I also have to admit that the industry legacy is currently not being able to cope with the big demand. So it's also us, the industry, which has to increase the capacities in engineering and also in production to cope with the big demand of heat pumps.
Thank you very much, Raymond. You put several very important points, and I'll come back to this, that industrial energy consumption is actually the one that usually also drives innovation. And hopefully that the pilot projects or the first projects that have shown good results may be supported and scaled to other industries as well, because we really need this example. And also, yes, the pricing incentive is completely now messed up. As an economist, I will take the blame if someone else here wants to take it with me. But the past few years have shown that, unfortunately, we're not going in the proper direction there as well. So hopefully this will change, and more the heat pump technology will get into industrial electricity consumption. Thank you very much for the input. And Mr. Beloreshki, what do you think about these two topics? So the possible partnerships, the challenges that we face, and how to tackle them.
Yeah, this is exactly, I'm a big proponent of exactly that, because once you are focused on one technology only, you're missing a lot of opportunity, which could be a win-win. Why I'm saying that? Because obviously replacing the coal-fired power plant with a solar or whatever is a win-lose. That's definitely the case, right? So you can expect some legacy producers to be against that. That's normal, that's natural. We can expect that. On the other side, what the heat pump is all about. Let me just ask the audience here. District heating, right? Let's say, for example, district heating, Sofia, this is the biggest consumer of natural gas in Bulgaria. 50% of the gas consumption is there. And we have now excess of solar. We are doing a curtailment, right? And on the other side, we are using gas to heat water. And they have a 360 whatever Bulgarian levs per megawatt hours, which is ridiculous, right? And okay, I understand that, right? The SO wants rotating equipment, they want base load fast. That's fair enough, right? We understand that. But we said, okay, this is what you need, right? But you want gas. So let's meet your need with something else, which is cheaper. And cheaper is eventually heat pump. When you have a heat pump, we have because of performance leverage of 3 times on average, right? So 1 kilowatt hour of electricity, you receive 3 kilowatt hour of heat. And let me tell you, I have done this personally because I believe, if I believe in something like that, I have to try and to do that. I did exactly that. I changed my gas fire heater at home with a heat pump. Of course, I was keeping the gas one, right, as a backup. Actually, exactly this happened yesterday. There was some problem, but I still have the gas to back up. So, but what I'm trying to say is that this is absolutely applicable for toplification, even without the heat pump. Just put a normal standard heater, you have an efficiency 100%, right? But going back to the electrical operator, when you have a heat pump, right, and it's operational, and let's say you have a disturbance in the network, you just reduce the load of the heat pump. That's it. So you're becoming in demanded response very easily. It can be even on dispatch of the operator. So you meet the need of SO, right, regarding the balancing. Okay, if you have reactive power, other things. But what I'm trying to say is that nowadays there are so many additional technology that the common sense needs to prevail, but it happens only when the discussion is happening. And it's very normal if I'm working in a nuclear power plant, of course, I know nuclear, I will push. It's natural, nothing wrong with that. I have been in coal fire. I said, okay, I know coal, we can do this by coal, and all that. But at the end of the day, it's the society that pays everything. Okay, investors are important, fair enough, right? But at the end of the day, if we want to really switch the needle, to move the needle, we need public support. And public support doesn't work when we are saying, okay, solar is very cheap, this and that, and then the next day, nuclear power plant, and they want 30% increase of the price. And what I'm personally doing on that area, for my mother-in-law, she's living in the countryside, and she was using wood because it's a village, right? And we just said no. So we put a small heat pump, air conditioner, right? But it's actually working like that. And you know what? On average, it's 50 left, which is 25. Okay, one room, but old-fashioned, non-isolation, and etc. So for 50 on average for the heating season, 50 left, which is 25 euro per month. And just 1 cubic of wood was 100 plus. So with one shot, we killed many things, right? And this should be a national program. And now everybody at that village, they start using that because they said, okay, this is the way forward. I wanted to go the next step because there was a program for individuals, program by the government, up to 50,000 lefs or whatever, which is exactly what it's absolutely needed for her, including the battery. Because, believe it or not, the consumption, an average consumption was around 350 watts. So this is the consumption of the air conditioning for that room. And the other thing which was interesting, she's switching off the air conditioning 10 o'clock at midnight. Yeah. So actually, solar, let's say 4 or 5 thousand watt hours should be absolutely sufficient for one room to go through that. And other things, you don't go outside where it's slippery, taking you. So we are solving very basic need with practically with zero money, and not even that. In the villages, people who are below the energy poverty line, whatever they call it, they're giving them cash. They're giving them cash to solve the heating, and what is happening with the cash? Cash is burned for something else. That's it. And they still cut trees for that. So if somebody asks me, I will make kind of understanding, not the order to not use wood for heating. It's very simple.
Yeah, but then our renewable energy share reporting will go down. Maybe you know that we report about 70% of it with biomass, so we have to be careful. Okay, I fully agree with you, and when we talk about paying the bill, it's either the taxpayers or the consumers. So always someone pays the bill. And I really hope that in the future we'll have like a symbiosis between, let's say, electricity and gas, like matter and spirit, yin and yang of energy transition, because electricity and gas, being hydrogen gas, I mean, this can really make them work together very nicely. Maybe that's one possible alternative future that we'll be looking at. Thank you very much for the input. Mr. Tabutov, what do you think about partnerships and challenges? So where do you see the low-hanging fruit and the challenges we need to solve?
Probably very quickly, I think the main challenge is that there is a lack of understanding of the economics behind the existing technologies that are out there, as we said, heat pumps, electrolyzers, green hydrogen, and also energy storage solutions of different variety. We don't have a critical mass of experience that the investors and also consumers can rely on, and it's not widely popular, so that we can really commercialize all this as quickly as we want to transit into the green economy. So through partnerships, this can happen quicker. Through also, I think, government and also local support schemes that can really somehow expose the good practices. So that's what's missing at the moment. To be very
Yes, demand side economics, not supply side economics in policy measures. Okay, thank you very much. And now we have a few minutes for questions, Q&A from everyone who is together with the other half. We started a little bit later, so I guess that we can use these spare minutes after the exact hour. Please, you have the floor if you want to share. Yes, I think this is Nicola. I hope he is not closing the conference before asking a question.
No, thank you very much. It was a very interesting and somewhat different discussions than the ones before. I'm going to ask Mr. Tabutov something, because I know very well what his company does. HEC Solar is a member of UPSTE, and I know Mr. Tabutov is very active also internationally. Have you actually worked on projects where solar power or hybridized renewable projects have been used in reality for producing renewable hydrogen, or are you working on projects that plan to have such facilities, basically having electrolyzers as consumers, off-takers of the renewable electricity to be produced?
Unfortunately not. We're working with a lot of international IPP companies and developers on a global level. As a tendency that we see at the moment is plans to integrate more and more BESS systems. This is as far as it goes. However, with all the developers that we work, there is only probably 10 or 15% of them already have very little pilot project experience with battery storage systems. Okay, UK market is a bit different. Their legislation was promulgated much earlier than within the EU, so that's by far the most experienced free market on standalone even battery storage. But within European Union and the companies we work with, there are only very little number of projects that integrate at the moment 2024 battery storage. We see huge demand coming in the next 2 years for us to integrate battery storage, but nobody of those guys is talking about electrolyzers co-location with Twin TS, but electrolyzers at the moment is not on the table. We don't see that, at least with the companies we work with.
And then maybe straight away to Mr. Ivanov, because you're the one who is, let's say, in the avant-garde for producing electrolyzer technology components. Are there any specific projects you're looking at now, let's say in the region here in Southeast Europe, be it in Bulgaria or in neighboring countries, that are going to use your technology, or where you're competing to basically be the supplier of the technology for projects that are using renewable electricity for the electrolyzers to be installed?
Yeah, thank you for the question. Actually, the answer is, let's say, pretty easy, because I think last week or 10 days ago, they announced the first tender from the European Hydrogen Bank. And for the first call, they are allocated 720 million euro for such kind of projects in Europe. So I think that, and if I'm correct, they have to be fully functional in the next 3 to 5 years. So I think that we will see such kind of projects.
Yeah. Thank you,
Pretty
Nicola.
soon.
Oh, sorry.
Yeah.
I hope that if a joint venture goes out of this, we can get our commission fee. Okay.
Absolutely.
Yeah, very interesting questions indeed about new projects combining different technologies, and hopefully we'll see more and more of this. Again, this also will need some additional regulations. I still believe that we are underestimating the power of the bottom-up approach. So it's quite easier to go into industries, like Raymond also was saying in his presentation, than making a support scheme top-down, like all the technologies, because there are many and so on. So distributing this power of innovation to industries and going to specific sectors may be even more interesting. Okay, we have time for one more question, or we are so late that it doesn't matter so much anymore. Yeah, we really have time for one more, if not, I would like to thank everyone for joining the panel, especially the panelists, for their interesting shared experiences. Hopefully some joint ventures will actually get out of this conference from all the shared experiences and businesses who presented here. And hopefully all the challenges that we have discussed will find their way into legislation, regulatory framework, and our thoughts going forward in the energy transition. I would like personally to thank the organizers for their efforts to make this conference possible. I know it was a big effort again this year, so thank you very much for inviting us and for making us comfortable. And maybe now it's time to give the floor again to Nicola, but first applauses for our panelists. Thank you.